Hemi head that come off of the new engine, and this is the intake that I've made. And Brad has already got in here and worked on this intake, and he textured it so that it'll have a lot more air turbulence. You can see how he did a lot of texturing in there. But right here, where the intake manifold meets the intake port, I got a lip here. I've got a lip around here, and I've got a little bit of a lip on this side. So what I'm going to do is just kind of bevel this lip in, because if I grind all this out, it's going to make it really weak. But I want to just kind of bevel this a little bit. I'm not going to bevel it all the way back to this edge, but I am going to bevel it in a little bit and bevel it here, because we've taken a lot of material out of that intake runner. And we're going to spin around to the exhaust, and as you can see, the exhaust really hasn't been touched. But if you look down in the exhaust runner, you see how it narrows up in here and narrows in there, and then it goes in and it curves down back in there. You'll probably see it better if I flip it over and you look through the valve seat. Anyway, if you let me find my pointer here that I'm using. Can't find it on camera. There we go. Alright, you see how we have a shiny metal up here? That's a steel. And then down here it's a darker metal, that's aluminum. And if you look over to the side here, we've got all that material right here we can remove. We can remove all this aluminum all the way up to the valve seat. And on this side, the same thing. We can remove all this on this side here. And there's a little bit here next to the valve guide I can remove, and then you see the valve guide right here. You don't want to mess with that. But there's some aluminum here that I can remove inside that head, and then polish this thing out smooth so that I'll have real good exhaust flow. You want your intake rough, and you want your exhaust just as smooth as possible for better flow. And where's me a good spot? There we go. Now you see this edge here, how thick that is. There's a lot of material that I could shave off of this head, and what it's going to do is it's going to make my compression chamber smaller, so I'll have higher compression. But the other thing that does, if you think about the engine this way, your crank is here and it's pushing the rods up this way, which operate your rockers, and it opens your valves. So if I take a few thousandths off of the bottom of this head and bring it down, let's say to the thickness of this throttle linkage that I'm using, if you look, that's a couple thousandths of an inch I could take off there, and not only is it going to make my compression chamber smaller and give me more compression, but it's actually going to give me more lift and duration on a stock cam. So I'll be basically, by shaving this down, I'm turning a stock cam into a high lift cam. Pretty cool, huh? And all it requires to do that is a sheet of sandpaper and some time, and you can shave this head down and turn that stock cam into a high lift, longer duration cam, because it'll start lifting the valve a little bit sooner as that cam goes around, and it'll lift that valve higher so that valve will stay open longer, allowing more intake gases to go in, and then when it opens the exhaust up, it'll allow more exhaust gases to go out. So for a sheet of sandpaper, you can modify your compression chamber, And you can also modify your cam without really even touching the cam. So anyway, we're going to finish this up here. Okay, we got our sandpaper tape down. And I think this is 120 grit, something like that. Anyway, this is one of those things where you don't want to get into a race or get into a big hurry. You just take your time, pay attention to what you're doing, and if you want to do what I'm doing here, just take one of your stock throttle linkages. This is a Hemi head here, Hemi engine. You see how much aluminum I've got there as opposed to that stock throttle linkage. And this is just, I mean, you could take a little bit more than this off of this, but this is just kind of a good general rule of thumb. But you lay that on there, and you see how much material you've got you could take off. And all you're going to do is sand on it a little bit, and then check, and whenever you get down to the thickness of that rod, that's a safe spot to stop. You don't want to go a whole lot more than that. You can, but you want to do the Play-Doh trick after you get thinner than that. But realistically, whenever you get that combustion chamber down to about that thickness, then you can shave some off the head, because your combustion chamber is actually going to be smaller than your piston, and you'll gain more by taking more off the engine than you will the head after that point. But don't ever take any material off of that engine block unless you really know what you're doing. You don't want to do that from you don't want to learn how to do that from a YouTube video. You want to go and have somebody that knows how to do it, and somebody who's done it, to teach you how to do that. Otherwise, you can ruin that engine. But what I do is just about the weight of my hand on there, and then I push and quarter turn. And this is all I do, and I might sit here for an hour or two doing this. But it's worth it in the end. You could do it with a belt sander. I just don't like doing it with a belt sander. I think this is more foolproof, because with a belt sander, it's real easy to make a mistake and plane this wrong, so that you'll have some gone off of this side and not enough gone off of the other side. Or if you go and you look at it, you set it on there, it could bump and roll, and it can actually take off too much down here where your rods go through on your head. And I mean, it's real easy to mess up if you use a belt sander. So I don't do the belt sander, I do it all by hand. Alright, so I've worked on this for about a half an hour, and the angle, sorry, if I can get the angle right, you can see I'm pretty much the thickness of that throttle linkage rod now. So I've probably taken the thickness of one of these linkage rods off of that head. There you go. Now you can see how thick that is. But I've taken that about half the thickness, or well, about the thickness of that rod off of the top of that head, which is going to make my combustion chamber quite a bit, several cubic centimeters smaller. And you can see how much aluminum powder I got off of that head, and then I got all that there too. So that's actually quite a bit there that I've taken off, and I've swept this off the table a couple of times already, but that's kind of my last run through. And now I can save that aluminum powder and make me some valve grinding compound out of it, and grind these valves, or lap these valves down a little bit. And that'll also help out with the performance, because I'll have a little bit bigger valve opening when they open up, because there won't be quite as much lip on the valve. and it'll allow for more fuel air mixture and exhaust gases to pass through the head. So yeah, it's another freebie performance upgrade to try to simplify why I'm doing this. Excuse me. All right. There's a couple of different ways to gain cheap power. Of course, one of the first upgrades you need to do is your heavier valve springs, be them 18 to 23 pounds, whatever you decide to put in this engine. Another way is by porting out the intake and exhaust on the head, which is going to allow more air flow in here. It's going to reduce the restriction, so that when your piston goes up and down, it can move more air quicker. And that's whenever you remove the governor and you port out the heads, you're moving a lot more air, and a lot more air in and out equals more horsepower, because this is basically an internally combusted air compressor, and air compressors move a lot of air just like an engine does. Now, your combustion chamber, which is what I was shaving down earlier, right here, you make that smaller. And the reason why you do that is, by the way, this is a insulin vial. I'm a diabetic, but this is the easiest way that I know to explain how shaving the head on one of these engines works. Okay, if you take a syringe, and the syringe is like a X amount, let's say a 1 cc syringe, and you fill it up with air, and you stick it in this bottle, and you squirt this bottle full of air, your air inside this bottle is going to compress. And the higher PSI of compression that you get in this chamber is more horsepower, because it makes the fuel and air gases more compressed, so they're more explosive. So with more compression, you have a bigger explosion, which means that bigger, more efficient explosion is going to force this piston down harder and gain you horsepower. Now, there's a couple of different ways to get your compression up. One of which is to bore this cylinder out and put oversized pistons and rings. Or, if you want to think about it with the insulin bottle, is to get a bigger syringe. So if you got a 1 cc syringe and you put air in here, you have a certain amount of compression. And if you take a 2 cc syringe and you put that full 2 cc's of air in this, you're going to double your compression. But you're not actually going to go up a double size on a piston on an engine, of course. But that's just a simplified way of putting it. If you double your air going into this chamber, you double the PSI, or you double the air that goes into the combustion chamber, you double your PSI. Now, that's one way of doing it, by boring this out, bigger pistons and bigger rings. A cheap way to do it is to shave the head down like I did. Or in other words, you have the same size syringe, but a smaller bottle. So the same volume of air goes into that bottle, but it's a smaller bottle, forcing the air to compress more that way, and you gain horsepower that way. And this is a really cheap route on gaining horsepower, is by shaving some of this head off, so you make this compression chamber in here smaller. Even though you're getting the same volume of air in, you have a smaller chamber, so it ups your compression, and hence it ups your horsepower. And then, of course, when you shave the head, you get more duration and lift on your valves with the same cam. So you're allowing more fuel air mixture in and more exhaust out by the longer duration. And then, again, with your port and polish job, you have less restricted airflow in and out of this engine, which means the air can move faster, it can get into those chambers quicker, and you get more to compress. So that's why we do this to these engines, if we want performance, and these are real dirt cheap performance mods that you could do to these engines. The 18-pound springs, $15 plus shipping, let's say $20. $1 piece of sandpaper, and you can do that with a file if you want to, or you can use a Dremel. And the file to do that costs $10. And then whenever you get all that done, you can get you a set of drillers, drill bits, and drill your jet onto your carburetor, on your stock carburetor, to 35 thousandths, or you can go and get a Mikuni or a Mikuni knockoff and put it on there and allow more fuel and air mixture into that engine. But now you kind of, you know, understand, if you didn't already, now you kind of understand why I do these things to these engines, and, you know, why Brad, you know, me and Brad do this, and why they work the way they do, and how it works is by bigger air volume being compressed into a smaller chamber gives you more horsepower, and then more air in, more air out, less restricted air going in, and then the dimpling that we do inside the intake causes the fuel and the air to turbine and roll inside there, and it mixes it, making the mixture a little richer, which makes it even more explosive whenever it's compressed into the cylinder and ignited. Okay, I'm done rambling. Let me get back to it. So I've been working on the exhaust, and I still need to do a final polish on it to shine it up, and I just dumped my entire Dremel kit on the ground. Yay! But alright, I got some polishing to do on that yet, but I've opened the exhaust quite a bit. All that right there and all over my leg and the floor is from the exhaust, so we ought to get some pretty good flow. And then I cut back right up there by the valve seat. I opened up the two sides, and as you can see with the runner, I can shove my finger all the way through now. And on the other side, that's one of my big old fat fingers there. I can run through all the way to the other side. And before, when I'd run my finger in, my finger would make it to right about there before it'd get stuck. And he's opened way up and go all the way up in there. Same with the exhaust. Before, I could only get my finger up maybe right in there, and now I'm all the way up to the other side, so I've really opened those both up. So I'm just about ready to start lapping the valves, and then after I lap the valves, we'll put it back together, well, and polish the exhaust a little bit. Alright, now it's time to lap some valves. So what I do is I use a little bit of hand cleaner. You could also use toothpaste, and I use some of my aluminum scrapings, and I put some around the edges of the valve like that, and then I use my index finger on this side and my thumb on that side. My finger is to adjust the pressure, because I'm basically pinching it between my thumb and my middle finger there. And that adjusts my pressure like that. just like that. And what I try to do, let me wipe some of this off, is I polish that lip, and I'm polishing this lip in here where the valve seats. And you see how good of a shine that's got on it? Now, there you go. Now you see the top edge of the valve? I try to get that about the thickness of a fingernail, which I've already messed with this one a little bit, and I've got a good lap to it. I've got a good angle, so it's going to have a good seat. And I'll wipe that out. You can see how shiny that is. So when that valve seats, I'll get a better seal. And I'm also helping that valve to clearance a little more and drop down in there just a little bit more. And whenever that valve is cleared and it's down in there deeper, that means that the valve stem was just made a little bit longer. So when the cam comes up, it's going to open that valve a little bit longer, a little bit higher. It'll have a little more clearance, and it'll allow more fuel air mixture in or exhaust out. And also having that nice tight seal, I'm not going to have leakage from exhaust gases or intake gases blowing through the valve seat, and that'll also help me with my compression. Put this back together. Now there's the exhaust, there's the intake, and there's something missing on that intake. Valve seal. The intake on these engines has a valve seal that slides down there. And it seats all the way down. Let me turn this stupid light on. There we go. But that goes all the way down. And seats down at the bottom, and okay, it's easier with two hands, of course. Anyway, when you put them back together, make sure you get that valve seal on there. Easiest way to put that on there is to take the valve out, put it on there at an angle, and just push it on and push it down. Alright, now we have a problem. These are 18-pound and stock springs. How do you know the difference? There. How do you know the difference? Well, of course you can squish them like that and see which ones are tighter. Yeah, that's an 18-pound. Those two are stock, but your 18-pound springs are going to have the paint mark on them. See that green paint mark? That's the one on the other one. So you'll drop your springs on, and you'll take your valve cap like that. You just set your thumb on top, push it over, down, and back, and it's on. You don't have to have a real big, fancy, expensive tool to do this. Just to set your thumb on top, over, down, and back. But it's easier with the tool. It's just because these springs are pretty stout, and I've got a sore thumb. Darn it, I gotta switch hands on there. I had to use 2 fingers on that one. Alright, and we got our alignment pins. Push them in. You got 2 on the Hemi. The non-Hemi will have 2 also. There'll be 1 here and 1 up there on the non-Hemi. And if you look, That's drilled for 1 too. So if you got the right size pins, you could do all 4. But all you need to do is just put them down here in the bottom. And you see this hole right here? There's a hole on your gasket that lines that up. I'm getting pretty good at this one-handed mechanicking thing. And oop, we got a paper towel on that valve. Yeah, there we go. It's gone. Shoot, that plug wire is just getting in my way. There we go. Now we're ready to put the head bolts in. And something you got to watch for. You see that? That's not seated all the way. Now it is. And then when you put these caps on, those caps keep that centered so that that doesn't bump over and come apart on you. See, those caps will keep that space so it doesn't shift over and your valve retainers pop out. So let's put some head bolts in. And you see that little bitty tiny hole way down there? And that one way down there? Those are your lifters for your push rods. So when you put your push rods back in, make sure you look down in those holes and the end of your push rod go down in those holes. Otherwise you're going to be fighting to try to put the valves together and it won't do you no good. We've got our rods in, we got our E-clips in, rockers, and we got our head tightened down. Now if you do not have a torque wrench to put these on here, and now the Hemi and the non-Hemi, I found that it's a 12mm socket to put those head bolts in. I know a 13mm kind of fits, and a 1/2 inch kind of sort of fits, but it's a 12mm to put these bolts in. And if you do not have a torque wrench, come down until it's snug, and then I give them a 1/4 turn more. So you see where that right there is set up, and that's about like a hand clock, like 12 o'clock. Whenever I tighten that down, I'll start it up at 12 o'clock and I'll bring it over to 3 o'clock, and that's good. And then I go down here 12 o'clock to 3 o'clock, and then up here 12 to 3, and then here 12 to 3. And that's just kind of a general rule of what I do, but coming down to snug on me is a little different than you. I don't want to put no more than 20 pounds on these things. So if you're at 12 o'clock and you come over there about 1, maybe 2 o'clock and that's tight, stop. Because you don't want to horse these down and strip them out, because you might have to take them out later and you might wind up stripping them out trying to take them out. It don't take a whole lot to hold that head on. Anyway, we get the head on. And you know what? I think I'll call this video good, because next we're going after the governor and the low oil sensor and all that, and we're going to be doing the plug wire and the E3 plug. So we'll call this one good. I know it's running pretty long. We'll see y'all again later.